Okay. So ABC is the triangle. Let's start drawing the figure. ABC is the triangle and E divides AC so that if this is A, this is B, this is C, then AE is to EC is 4:1. So suppose, okay, and the next thing they have said is AF is to FB is 1. So F is the midpoint of AB. The ratio is 1:1. And D is on side BC such that the intersection of AD and EF is G. So this point is G. And AG is to DG is 3:1. AG is to DG is 3:2. 3:2. The ratio BD is to DC is A is to B, and we have to find this ratio A is to B. Now suppose instead of A and B we keep the ratio as lambda is to 1, it will be easier. We will have to find only one variable. And they have not said anything about the coordinates of any of the points, so we will just assume our own coordinates. So let A be the origin 0, 0, 0. Let the position vector of C be C bar, B be B bar. Then the position vector of F will be B by 2 because F is the midpoint of AB. And using the section formula we can find out the position vector of E. It is 4C plus 1A upon 4 plus 1. So 4C is this, 1A will be 0 upon 4 plus 1 is 5. And next the position vector of D. Now it will become lambda C plus 1B upon lambda plus 1. So it is lambda C plus B upon lambda plus 1. This is D. Now let us write the position vector of G in the same manner. So it is 2A 3D, 2A plus 3D upon 3 plus 2. So G is equal to 2A is 0, 3D, so 3 into lambda C plus B upon lambda plus 1 upon 3 plus 2. So that is upon 5. Okay. So this is the point G. And another thing to observe over here is G is the intersection of line AD and EF. So we can safely say that G, E, F are collinear. And we know that when 3 points are collinear, then it means that every point divides the other 2 points, the line formed by other 2 points into some fixed ratio. So suppose we consider the case EF, mu EF is equal to GE. So this will be okay because points EF and G are collinear. So we can write this. So that ratio is mu. It doesn't matter if the ratio is internal or external, it's fine. So using this newfound equation, let us write what we have. So E is 4C upon 5 and F is B upon 2, and that into mu is equal to GE. Or let us do GF over here instead of GE. GF will be easier. It doesn't matter really, you can do anything. It's just for our convenience. So GF. And then G is 3 upon 5 lambda C plus B upon lambda plus 1. This is G, and F is B by 2. So now we know that C and B are non-collinear. So to equate these two, we will have to equate the coefficients of C and the second we have to equate the coefficients of B. So let's get to that. The coefficients of C, so this is mu, 4 mu upon 5 is equal to 3 lambda upon 5 lambda plus 1. And the next equation is equating the coefficients of B, so that is minus mu upon 2 is equal to 3 upon 5 lambda plus 1, and it should have been a minus b over here, not plus b. So this is minus b, and here we have minus 1 by 2. Okay. So now to solve this, let us divide both of these equations. So mu will get cancelled and we are left with only lambda. So let's write down the equations. 5 also gets cancelled from here, and we have minus 4 into 2, 8, minus 8 by 5 is equal to, this will be 3 lambda into 2 upon 1 minus 5 lambda. Minus 8 plus 40 lambda is equal to 30 lambda. So lambda is equal to 8 upon 10. So that is equal to 4 upon 5. So our A is to B is 4 is to 5 and A plus B will become 9. So 9 is our answer.